Did we lose Mark? Oh. Hey everyone. All right, I think we still have Mark. Hopefully we do. All right, well, welcome to lecture number 9. And I'm just going to give a couple quick announcements and we'll hand it over to our guest speaker for today. Let me go ahead and do a quick screen share just to remind you of where we are, because you do have some assignments coming up, some due dates. So let's see here. All right. Okay, is that screen share coming through, guys? I don't have my secondary monitor up right now.
Yeah.
Yeah, okay, perfect, great. All right, cool. So here we are on October 8th, so it's our second guest lecture. Just the main thing I wanted to remind everyone is that you do have 2 things coming up that are due. So Module 2 Programming Challenge is due Monday night at midnight. And you'll have your Module 2 quiz. That'll be on Monday, is that right, Arvind and Rohan, the quiz?
Yes, Professor.
Okay, cool. And that's asynchronous, so you can take the quiz whenever you'd like on Monday. As you're studying for that, as usual, the best thing to look at are the questions that I've asked you in class. That will be the best thing to look at. And this quiz will be more conceptual than the previous one, so a little bit less math. And the last thing to look out for is that make sure you know your definitions of precision, recall, overfit, underfit, variance, bias, all that good stuff, all those big concepts that we covered. So that'll be on Monday. And please do not forget to submit your final programming challenge submission on Canvas. That's how you get your official grade. And then finally, make sure that in the programming challenge that your work is your own. So the only person you can plagiarize from is me. We will run anti-plagiarism checks on your code, and if your code is too similar to any other students, then we have to report you, unfortunately. So make sure your work is your own. We say this every time, but every year a few students forget that. So don't forget, we don't want to have to report anybody this year. So those are all the announcements I have. Arvind and Rohan, any other announcements before we hop into Mark's lecture?
I would like to add one more point about the quiz. So for this quiz, we have an extra credit question. So you have to do 6 questions below 5.
That's right. Yep, absolutely. So yeah, we have an extra credit question for you guys this time. And this is going to be kind of an open-ended free response question. It's about one of the concepts that we cover in the lectures. And we're kind of asking you to explain that concept. So a good way to prepare for that is to have a look at the big concepts in the lecture and make sure that you're comfortable explaining those in a paragraph or 2. Anything from you, Rohan?
No, Professor.
Great. All right, well, cool. Let's get started here. I'm going to turn off my screen share, and I will give just a quick intro to Mark, and we'll get started. Great. All right, so we're really happy to have Mark Hayworth with us today. He is a senior scientist at P&G, Procter & Gamble. He's also a technical advisor at the MathWorks and a big contributor on the MATLAB forum. I'm curious how many students have worked with MATLAB before. That might be a fun poll to run later if we have time. So when I went to undergrad, the first language I learned was actually MATLAB. That was back in 2005, a long time ago now it feels like. 15 years, wow. And I switched to Python later in my career just because of different things that were going on, but MATLAB was my main programming tool for a long time, and you can do some really cool image analysis stuff in MATLAB. So just the last couple of things I'll say here just briefly. So I met Mark after a conference, and he has just a huge amount of experience in applied image analysis, so it'll be really cool to hear what he has to say today. Please bring your questions. We'll do our questions like we normally do, so I think Mark will have a few times where he pauses, and feel free to throw your questions in the chat. We may have Mark look at those directly, or if it makes more sense, the TAs and I can kind of read those questions and then ask whichever ones we'd like to have Mark have a look at. So we'll figure that out as we go here. But without further ado, I'll hand it over to Mark. So thanks for joining us today, Mark.
Okay, let me see. Share.
All right.
Okay. This is PowerPoint. So
yep.
I'm going to hit the full screen thing. So
all right.
Hopefully it will come up full screen.
All right, fingers crossed.
Try
all right.
Again, full screen.
All right, sounds good. Let's see. Loading.
Okay. Went to my desktop, all the icons. Okay, here it is.
Okay. Let's see. Oh, yep.
Can you see that?
So we see your presenter view, though, which maybe that's okay, but we see the presenter view.
Oh, really?
We do, yep.
Let me, how do I change the view?
Rohan, did you guys run into this problem when you practiced earlier?
This was the same when we practiced it earlier.
Oh, okay. Well, I mean, this is okay. We could live with that.
Let me just stop sharing. I will
Sure. You
go
may
to share screen. Let me just change.
If you share the whole desktop, it might, and if you can choose which monitor, it might do what we want.
Share PowerPoint slideshow image. Let me try that.
Sure.
Share.
All right, loading.
Just the one screen?
Oh, nope, that's it. That's perfect. You got the whole presentation. Looks good to me.
Okay, so this talk is just for me. My coworker is not going to be on this talk, but yeah, I got a BS in engineering physics with specialization in optics from University of California, San Diego. And then I really thought optics and imaging was fun. So I went on to the College of Optical Sciences at the University of Arizona, and I got my MS and PhD there. And then after that, I went on to P&G in Cincinnati. And I've been there for 30 years. So I've actually been in the imaging field for about 40 years now. So quite a long time. So here's some fun facts about P&G. So we're headquartered in Cincinnati, and you can see, actually, if I get out of the way, that's P&G in the background behind me. That's the back of it, and then on the screen here is the front of it. So we have 14 technical centers around the world. We got about 100,000 employees, about 14,000 in Cincinnati. We have 8,300 people in R&D. We have over 1,500 PhDs, which is like more than MIT or Stanford. We're right now are doing about 68 billion in annual sales, and we spend $2 billion on R&D. And we're number 50 on Fortune 500, number 23 on Fortune's most admired list, 11th biggest market cap, and we're the second oldest company on the Fortune list after Dow DuPont. So P&G was founded in 1837 by a candle maker and a soap maker. And our products are sold in over 140 countries, and 90% of the world's population can buy one or more of our products. And I actually think that's pretty cool because, you know, you talk to people and they're like conferences, oh, I'd make this kind of gadget, and, you know, maybe 100 people will use it, or maybe 1,000 people, you know. Well, you know, I work on like laundry detergent, and you know, I've got 6 billion customers in the world. You know, so, like, that's kind of funny. And in fact, P&G is the world's largest advertiser. Wow. We spend over $9 billion per year on advertising. That's more than 4 times what we spend on R&D, unfortunately. Like just during our talk, we're going to spend $1 million just on ads.
That's crazy.
Here's some of our brands. We've got Always, Bounty, Swiffer, Braun, Charmin, Crest, Dawn, Downy, Febreze, Gillette, Head & Shoulders, Mr. Clean, Olay, Oral-B, Pampers, Pantene, Puffs, Scope, Tide, Vicks, and a whole bunch of other ones. Only in the last 5 years, actually, have we started advertising like P&G. You know, it used to be before we would just do the brand, so a lot of people didn't know that the brands were P&G, but now we'll, you know, maybe at the end of the commercial we'll say, you know, buy P&G. So what is image analysis? I think you guys pretty much all know this. Basically, you take an image and you measure things, and you get measurements from the images. So we acquire our images from a whole bunch of different we have so many different ways of acquiring images. It's unbelievable. We have video cameras, we have digital still cameras, profilometers, line scan cameras, microscopes, flatbed scanners, pressure sensors, CT and MRI. And we've got a whole slew of chemical methods that these chemists have, like MALDI, DESI, mass spec, XRF, TOF, SIMS, different spectroscopy methods. You know, there's a ton of chemical instruments that can produce images, and quite often they don't give the, you know, the CAN software doesn't make the measurements they want to measure. So I will do some signal analysis or image analysis on their chemical data. So mostly we use it as a small scale R&D, like, you know, we'll take a product, image it, and make some measurements. Personally, I don't get into the online stuff, manufacturing line stuff, like the professor does, you know, but we do have people in the company who do that, who are like looking at diapers flying off the line at, you know, hundreds per second, and they've got things to image those. But, you know, I just do more of the R&D lab. But I have done some consumer kiosks where we're looking at skincare or dental applications, and I'll show you one of those. And so, so we want to do image analysis because it's more objective, it's more sensitive, it speeds product development, and it results in fewer studies with fewer samples, and saves time and money as compared to like, you know, consumer visual grading. So a lot of times someone might start off small and they'll have people grade something like, I think this is a 1, I think this is a 10 or whatever. And, you know, it's very imprecise, and they want to make it more objective. And so we do a lot of replacing human visual grading with image analysis. And so we have, there's about 20 people in our company that are, you know, kind of considered experts in image analysis. This is people who actually can write code, develop mathematical algorithms to make measurements, and they usually have degrees in computer science, optics, or electrical engineering. Or sometimes there's like a new field of like data science. So there's a lot of like, you know, people who know how to do deep learning sort of from a computer science background. And then we have about 500 other people in the company who are like end users of, you know, image analysis programs that we write. And literally I've done probably at least since I started using MATLAB in 2006, I think I've done well over 200, maybe 300 projects. Usually I'll probably have like one or 2 or 3 new projects a month come in, and at any given time my workload is, you know, I may have a portfolio of like 20 projects, and I'm actively working on like 4 at one time, and the others are maybe, you know, the ball's in the other people's court, and I'm waiting for them to do something. So anyway, we have international R&D installations in Japan, a couple in England, and Frankfurt, Germany, Beijing, China, Sao Paulo, Brazil, Singapore, and Brussels, Belgium. Are there any questions about P&G at this point? I can't see the chat windows, Stephen, so if there are,
oh, no problem. No questions yet.
All right, so this is our platform is typically a PC. Sometimes it's connected to an imaging rig of some sort, and sometimes they get the images through other means, and they just have images that are on like a you know, a shared drive or a server or something, and people analyze them on their own laptops or something like that. So then we'll make customized, we'll take commercial image analysis software like MATLAB or Viso, or some people use ImageJ or Visual Studio. And then we'll write a custom program that does like exactly what these people want. And it sort of frees them from the steps of like, if you had to use ImageJ and you had to go through, you know, 18 different steps all the time, you know, we just bundle that into one streamlined tool turnkey interface. So here's some light boosts that I've designed. This one, and I'll talk about some of these later. But this is a laundry stain removal light booth. So we basically take laundry stains and we stain a fabric with a bunch of different stains. We'll put them in here. There's a camera up top. It's looking straight down. It's sort of like an integrating sphere sort of environment. It takes a picture before, and then we go and we wash and dry the fabric, and then bring it back and take a picture of the after picture, and we find out how much stain got removed. Here's another one where we were looking at shine on hair. So if you take hair and you drape it over a barrel, it kind of produces a shine band, and so we wanted to measure that so we could tell how shiny your hair was getting.
Wow.
this is we call it glass eyes. It's a light booth. We basically have a light up here. The light shines down on the drinking glass that's here, and then the camera's over here looking at the scattered light, so we can detect spotting and filming on glasses for, you know, how well Cascade detergent works. We've got a floor scanner. So like if we're cleaning a floor with something like Mr. Clean or Swiffer, or you know, maybe you want to check anti-dust properties with Febreze, then you know, we have this is a line scan camera, so we put a tile down there and it goes along, and a camera images just one line at a time, and it builds up an image line by line, because normally you can't see the whole tile. This is like a 1 square foot tile here. Normally you can't see that unless you're like, you know, you kind of tip and tilt, and you see part of it good at some time and not at others. This is one we call tough food cleaning. So we have like a stainless steel pot, like here, let me see if I can, maybe I have to go over here. How do I get my laser pointer? Okay, pointer options, laser pointer. Okay, so like here's a stainless steel pot, and we'll put on like macaroni and cheese in there, or Alfredo or something. Here's a casserole dish and a plate. Put them in there, take a picture, and see how well the soil got removed from the plate. So any questions about designing light booths or anything like that?
Is that real hair?
In a way. So what they do for hair is, believe it or not, there's hair companies out there you can buy hair from. And then so to get hair, you want hair, if you're doing scientific experiments, it has to be uniform. But if you just go out and you just clip a bunch of switches off blondes' heads, they're not all going to be the same, right? So how can you test things? So what they do is they'll get hair of a certain type, like blonde, and then they'll somehow they mix it together. So you get sort of a, you know, like a blended blonde, and then you can buy that. I suppose maybe you could buy the individual ones, but you know, then you're going to have a lot of variability.
Right,
You know,
right.
even some kind of dishwater blondes, you know, they have kind of streaky hair.
Right.
And, you know, so I suppose you can get whatever you want, but generally we buy like kind of blended hair that's from real people.
Oh, wow, that's fascinating. So Abhijit has a question. He says, how does one quantify that the product has worked? And I bet that's about probably where you're headed.
Yeah, I got about 30 slides on that.
Awesome.
So of course it's different for each thing, because as you can imagine, quantifying stain removal off a laundered fabric swatch is going to be different than, you know, how shiny hair is. And you know, we've even done, like a long time ago when we used to own the IAMS pet food company, I had a project where we measured how shiny dogs were. Yeah,
cool.
believe it or not. So we would take like black Rottweilers and we would feed them, you know, like Sam's Old Roy junk dog food, and then we'd give them like IAMS Premium or Eukanuba, and you know, their coat would be shinier, and we would measure it, you know, by like how many glints were on their coat.
How did you get a good picture of the dog? Just to put that in a light box, or like?
No, we had a rig. It was like a DSLR camera, and it had like a frame around it, and we put it up to the side of the dog and snap a picture.
That's awesome.
Yeah. So, oh my gosh, you would. I could tell you offline some of the things I have measured, and you would be. It's unbelievable. Some of the things I've measured. If you know what P&G makes, like FemCare products and diapers and stuff.
Oh yeah, I
mean,
bet the diaper
just imagine.
Right. That's funny. We do have one P&G question here real quick. So Monica says, who is the biggest competitor of P&G?
We don't really have anyone that really competes in every category we have, but there are competitors in certain categories. Like Kimberly-Clark is certainly the biggest in diapers and paper products. And then Unilever's really big in hair and skincare and detergents and stuff. Also, there's a big German company called Henkel. They're really big into cleaning products. And in the oral care, Colgate is our big customer. So a lot of the other competitors sort of focus on certain areas. But yeah, probably Unilever and Kimberly-Clark. By the way, our biggest selling product is Pampers. And number 2 is Tide, or it would be Tide and Ariel if you combined them. The Tide's in the like half the world, and then it goes by a different brand name in like Europe. It's called Ariel. So that probably would be bigger. And then Bounty is actually, heck, now Bounty may be our biggest product since the pandemic started.
Oh, right, I bet, yeah.
Oh my God, you would not believe. I mean, our Charmin and Bounty, they just went through the roof. I mean, they were up like 30-40%. Even the shampoos. We found out people in Europe are taking a lot more showers than they used to.
But not us Americans. We're still just as dirty.
Yeah, a little more showers. We're selling, on average, we're selling about 15% more now than we did, pre-pandemic. So it didn't hurt us, actually. Our stock's gone way up during the pandemic.
Right.
Okay. Not sure why I didn't. Okay, so let's go. So this is what I call mug shots. So what we want to do is find out how well dishwasher detergents clean tea stains on coffee mugs. So we'll take a coffee mug and we'll soak it in some tea, and then we'll put it in the dishwasher and take a picture of it. But because you can't get a good picture of the inside of a coffee mug, we used the line scan camera and we basically spun the mug around. So we just we put a mirror down into the mug, and the camera kind of bounced off the mirror and imaged just one line of this mug, one column at a time, and then we spin the mug. So then we basically build up this image one line at a time. So this is kind of like if you took the coffee mug and you cut it and unrolled it or unwrapped it, it would be like that. And I'm not going to go into all the measurements we make, but we look at the profile and the uniformity and do some edge detection and look at the brightness. And I mean, literally there's like 30 different measurements we make on this image, because as you know, like if you look at someone, not like one picture doesn't tell the whole story. I mean, if you look at one picture, you can't say, he's an 8 and he's a 5 and he's a 9. You need to give more things. There's the height, the weight, the skin color, the hair color, the eye color, and so on. So a lot of times with our things, it's like you can't just measure one thing and say this is a whatever. We need to measure a whole bunch of things because it takes a whole bunch of different measurements to basically tell the whole story about what's happening here. Any questions about mug shots?
Yeah, we do have one question that came in, and I actually have a couple, but let me just ask one real quick, just because I think it's relevant to the class. So we just finished a module where students used edge detection. They used the Sobel edge detector, and we discussed more sophisticated methods like the Canny edge detector. What role is edge detection playing here?
Okay. First of all, let me tell you that I see in MATLAB form a lot of novices just say, oh, I'm going to use edge detection as the first step no matter what. And it's very rarely actually something you want to do. But on occasion it is. But most times people use it. You could just do simple thresholding, and not do an edge detection.
Right.
But the reason I'm using edge detection here is because if I just said, let's look at the mean darkness of this image, I would get one value. But imagine I took this image and I just sorted it. So it was sort of like a uniform ramp from dark on the left to light on the right. Yeah, I could have the same mean gray level for that image. Now imagine you took it and you rearranged the darkness into little clumps, like little spots. Well, that has a different effect on people. If it's a ramp, they may say, "Oh, I don't see anything there because it looks all smooth." But if it's all like clumpy and spotty, then you say, "Well, that's really bad." So what I did here was a difference of Gaussians filter. So I first did a full factorial. I did just like 2 Gaussians blurred and I subtracted them. So I just did a full factorial and I found out what combination of spreads on the Gaussians sort of gave the, a good visual effect for the splotchiness. And then so once I had that image, then I could take a mean gray level and then I could also do some particle sizing on it. So for example, let's say you had let's say that this image was rearranged so it was just like a smooth ramp from left to right. Well, the dog filter wouldn't give you anything because it's just a smooth ramp, and if you took the mean gray level, it would be 0 because there's no edges. But if I have this and I take the mean gray level of this, now it's a non-zero mean because, there are edges there. So that's what I did for this one.
Oh, very interesting. Yeah, so the edge detector kind of lets you know something about the structure a little bit, right? That it's not just a smooth gradient, that it's got some kind of spatial noise to it.
Right.
Very
Yeah.
cool.
I mean, if you took like an image and you just sort of like scrambled it up and randomized it, it would just look like white noise, right? And if you took like the mean or something, you couldn't learn much about that. But if it has some structure to it, you can learn something. But you have to just know how to apply the right things. So there's a lot of morphological things we do and intensity things, and I do a lot of color image analysis too. In fact, that's one thing I think is you should emphasize is color image analysis. I mean, if people don't know anything about LAB and delta E, they really should, because I would say probably half my image processing stuff has to do with color.
Oh, wow, that's very interesting. So guys, just so you know, we haven't done a lot with color yet. We will discuss color in some detail in Module 4. We won't get quite the way to, so Mark's referring to what's called the LAB color space. That's a really interesting area. We'll reference it briefly in Module 4, but we won't have time to get into a lot of detail. But color spaces are really a cool area, and there's some evidence for you that it's probably worth exploring a little more. And then we have one question mark from Sean here real quick. He just has a question about the line scanner. He's asking what is the width, what is the measurement or the width of the measurement that each line scanner image takes? It's just 1 pixel, is that right, Mark? Is that how it works?
It is just 1 pixel. And then a line scan is usually something like 8,000 pixels by 1. It's an image that's 8,000 by 1. And so when you scan something, you can get huge images. I mean, like a surface scanner, I mean, 1 grayscale image is 63 megabytes, and like 200 megabytes is a color image. So yeah, that we do have color line scan and black and white line scan, but yeah, it's just because you can. I mean, 1 line scan is only 8,000 pixels. That's way less than a like 20 megapixel 2D camera. So
right.
You often end up, after you stitch them all together, you do have images that are huge, like 8,000 by 9,000 pixels.
Right.
Quite much larger than just like a DSLR.
Mm-hmm.
All right, so I spent a lot of time working in diapers. So probably about especially since last November, so probably 11 months now. And I've worked in diapers before, but yeah, this was one of my earlier projects on diapers, actually. So we were sending diapers home with parents, and then they would use the diapers, and then they would roll them back up and send them back to us. And we would have people, believe it or not, they would take the wet diapers out. They would put it on a platform with an X-ray overhead, and they would take an X-ray of the diaper. And And by doing that, you can find out the fluid flow. So you know where, is a fluid concentrated at the center? Is it distributed all over? And things like that. Does it have, we're starting to put channels into the diapers to sort of direct the fluid lengthwise, and that helps make it sort of stiffer, but it also reduces sagging in the diaper. So, parents don't like to see like their baby with the ducktail with the, big old droopy saggy diaper, so you can design things to sort of like eliminate that, but we need to know where the fluid goes. So this is a custom user interface. This is a very common type of user interface, actually. We'll often have a list box of images, and then everything you can't just have a slew of buttons. You got to make it easy for these users, because they're like not sophisticated image processing people. These are like, just products research people. So it says step 1, select test folder, and they browse to their folder of images. And they need to maybe select a different file. They click on the file they want to show. Various options like send to Excel or whatever. And then there's a button that says like go, and it'll analyze all the images you have selected and throw the results into Excel when you're done, and pop open Excel when you're done, and you can look at your results. Or sometimes we actually write it to like, oh, sorry. I think my camera I banged on the table and the camera went.
Yep.
Sometimes we'll drop the Excel results onto a server, and then a stats program that a statistician wrote will sort of like pick that up and do some more sophisticated stats on it than you can do in Excel. Like a lot of times we'll do like Latin square studies, like a 4x4, like a factorial type test, but in a Latin squares pattern, which you guys probably don't know what it is, but it's a way of randomizing placement of things. So, and I might be able to show some more diaper stuff later, but anyway, any questions about x-rays of diapers?
Nope, no questions on that one.
All right, so another one, back when we owned Clairol, which we've since sold off, they were interested in hair colorants, and they wanted to know how much the hair dye penetrated into the hair. So this is, they would put they would snip off some colored hair, and they'd embed it in like a resin or something, and then they would take they would use a microtome to shave off little bits of it and then image them in a microtome or microscope. So this is a microscope slide of some hair cross sections, and you can see how it's kind of darker around the edge and then lighter in the middle. So this is maybe someone with light hair that was dyeing it dark.
Oh wow.
And you can see they're all different sizes and shapes. So I used a Euclidean distance transform to find out for each blob here what the distance from the edge was, and then I could get, and I found so for every pixel I knew its distance from the edge and its intensity, and so I could plot those. So this is like the average darkness from the edge of the hair for all those different hairs. And then by looking at this, you can kind of see like, well, where does it get dark and where does it get light, and how deep does the colorant penetrate into the hair, things like that.
Wow, that's really cool. So those are cross sections of individual hairs, and then a good dye might have a different profile where the dye would get deeper into each hair fiber.
Exactly.
Yeah, that's pretty cool. Well, that's awesome. And yeah, so the Euclidean distance transform, we won't do that in this class, unfortunately. I used it once at my old job. It's pretty neat. We did just do some Huff transform stuff. But if you guys ever have it's a cool area to look into in more detail. It's the distance transform. It's a simple idea, right? But it can be really useful.
Yeah, we actually do use it quite a lot. And in fact, I see it on the MATLAB forum a lot. So one common use is people have some irregular shaped thing, like a some snake-like object. It's kind of this, it looks like a snake or a worm, and they want to know, well, what's the average width of that thing? You know, so one thing you can do is you can take the skeleton of it, and then you can take the Euclidean distance transform of it. And then if you take the Euclidean distance transform and you multiply it by the skeleton, you're basically getting the radius as you go along the spine or the center line of that snake. And then if you take the you take the histogram of that, that's basically the histogram of width along your snake, right? So now that gives you the, you know, you can take the mean if you want. That'll give you the mean width of the snake. So yeah, you know, that's a common use of it.
Right, very cool. And we have one question coming in about would this method work? Would the method change at all, or would there be any changes that have to happen if a person had a different hair size or hair density?
Yeah, the hair size, no. But the hair density, yeah. I mean, if the hairs were touching, then you might have to do something like watershed or something to try to break them apart, because you know you don't want like figure 8 or dumbbell shaped hairs. So yeah, you know, we try to make sure that they're not touching. I mean, not that we can't handle it, but it's more difficult.
Yeah, absolutely. And are you using edge detection on this one?
No.
No, gotcha. Cool. Great.
This is a situation where if someone put this on the MATLAB form, they would say, well, I did edge detection on the hairs, and I have this problem is that the edges are like a C and they're not connected. Now I need to do edge linking. No, sorry, you
Right.
don't need to do that. I mean, you can just do simple thresholding, and you get something like shown on the bottom here, and then you can just do a hole fill and you get the blobs. No edge detection needed.
Right, right.
Okay, so floor cleaning. Yeah, this is another one. Actually, I'm not showing the stains here, but imagine there's a blob here of like dried raspberry jam, and imagine this is like a white enamel tile or something. So like someone, you know, dropped some jam on the floor and let it dry or something. So, and these things here are implements which are a combination of a scrubbing thing, which could be a Swiffer, could be a Bounty paper towel, it could be a cellulose sponge, it could be a scrubber sponge. You could put a fluid on there like a dishwashing liquid like Dawn. You could use water, you could use Mr. Clean, you could, you know, so whatever you want. And then basically these four things here, they go up and down, up and down, up and down, back and forth. And what we can do is I can look at the so we know what it looks like when the tile's brand new. And so I calculate the delta E, which is the color difference, as a function of stroke number. So you can see that it starts off here. Well, this is actually a stain removal index. So it actually starts off dark red everywhere. And then as the strokes go on, it gets cleaner and cleaner. So the stain removal index is kind of like an inverse delta E in a way, but it's basically how clean does it get. And so you can see that as it goes along, you know, these things here, like box 3, whatever was there cleaned a lot faster and better than whatever was in box 2, which, you know, took a lot longer to clean. So you can say that, like, if you define clean as like 70%, you can say, oh, you know, this one got it clean in 15 strokes, but this one took 40 strokes. And then you can make claims on your products like this cleaned in, you know, 1/3 the time. Or you can look at a certain time, like after 20 strokes. This is 20% clean, this is 70% clean. You could say, after the same amount of work, we got 3 times cleaner. You know, and you'd be surprised. I mean, I've done things and we've put them on the package and advertising. Just you do something like that, and then suddenly you've made $10 million or you know, $50 million.
Right,
It's
right.
amazing. You make the littlest change, but when you're making literally millions of or billions of products, you know, slightest change can literally mean hundreds of millions of dollars.
Yep, that's pretty cool. Yeah, I feel like personally, you know, sometimes when I see ads that say things like, "Oh, it cleans 3 times better," sometimes I kind of roll my eyes, like, "Oh, does it really?" But in this case, you really have the data.
It does, yeah.
Yep.
You have to, you can't just go and like cherry pick like the best situation. It has to be
Right.
reasonable, realistic things. Otherwise, your competitors will challenge you, and of course, we're being challenged all the time by probably Kimberly-Clark, who makes Huggies, is probably the most litigious company in the world. they're constantly suing us, and you know, we fight back, and sometimes we trade patents, we cross-license, try to work it out.
Right.
I might talk about a lawsuit later on that we had with Colgate.
Okay.
Let's see, how's our time doing? Oh,
We have about 30 minutes left.
okay. This is actually the jewel in my crown that I've spent the most time. I've been working on this literally about 25 years or more. This is laundry stain removal. So this is a user interface. So we have another app that actually calibrates by looking at the X-Rite color checker chart, which hopefully you'll at least mention at some point in your class. So we do a color calibration, and then we snap a bunch of images, and then we have images like this. And so we have two images. There's the before images, like here, and there's the after images here. And by looking at these, and you calculate the delta E, so how much did the color change from before to after? And then you can turn that into like an index of like, sort of like a percent removal. Like this got 50% removed, this got 80% removed, 20% removed. And some are, you know, more harder. We pick the super tough stains to remove, like dirty motor oil, and, you know, because if something is like real easy to remove, like grass or something, you know, I mean, that stuff, it just cleans up pretty easily. And how can you tell if you're making any improvements if it's all gone? So we'll pick like ones that are kind of like, you know, super tough, and we'll soak them in and dry them on and age them. And, you know, that way we can tell if there's a change. So yeah, this one we actually ended up, because of the results, putting some things on the package. And I don't know if I have them here, but I have pictures of the package where, and I have some TV commercials where there's some fine print, you know, based
Oh,
on
cool.
laboratories, you know, and say, hey, that's me.
That's pretty cool.
Yeah, so that's kind of fun when you work on something and you see it there, right there on the shelf in the store, and like, yeah, I did that.
That's pretty cool. And you said you worked on this one for a long time. Has the you know, why has it been such a long running project? Are there kind of new problems to solve, or does the image analysis, has that improved over time? What's changed over time?
Yeah, well, you know, camera models change. We did a change of light boost in like 2006. We went to a, you know, a better one. Our latest one, not much of the image analysis changed, but we had a lot of databasing stuff where things were being taken from and put back into a database. You know, things like that.
Right, yeah, absolutely. And we have one question from Abhijit. He says, how are these experiments designed? How does one decide to use X-ray or resins or microscope or something else? Are material engineers involved?
Yeah, that's basically the art of, you know, doing imaging. Is you got to have. So we have a big analytical department, and, you know, we kind of know what each other does, but, you know, and I'm an optics person, and I sit across from spectroscopists and other kinds of chemists, mass spec people, chromatography people. You know, so sometimes they'll want to know something, and, you know, at least I have to know how to refer them to. If it's something like visible, like, oh, I can see that, let's just take a picture of it, yeah. But if you have someone saying like, well, I want to know, where does the conditioner go with respect to the hair cuticles? You know, then I might want to say, well, you need to go to our laser scanning microscopy guy, and or our atomic force microscopy guy, and they can get you images of the hair cuticles, and you can see if they're like smoothed over or something. Or sometimes they say, well, we put chemicals A, B, and C into the shampoo, and we want to know, well, how much of it actually sticks and remains on the hair, and how much is, you know, useless, just gets washed down the drain. You know, so, oh, okay, well, we want to go to our XPS guy or our TOF Sims guy, and they can give you like a chemical map of how much of each chemical is where on the surface. You know, so we all kind of have to know what the other guy does, because, well, we might have to refer you to a different kind of thing. Like if someone says, well, I noticed that fabric softener seems to limit the breathability of sports fabrics. I said, well, we might want to do micro CT on them to see, are the pores clogging up, or are the fibers are getting coated with fabric softener, and we need to, figure out not how to change that. And then, well, maybe they are. And well, maybe do you need to have a different detergent for different types of fabrics, like one for synthetic sports fabrics and one for natural cotton fabrics? So you need to have chemists who know, that kind of stuff.
Right.
But yeah, a lot of times I think I have an advantage in that I had an optics degree and image processing. I did I did medical image processing when I was at the College of Optical Sciences at the University of Arizona. And yeah, so then I kind of got sick or burned out of, so this is a tip for you guys. I kind of got burned out of just doing medical image processing. I was in radiology, and I just had like 6 years of radiology, and it's like, I'm sick to death of radiology. I don't want to do any more radiology. And so I started interviewing, and I had like a company that they did fingerprint image analysis. Okay, but that's all they did. Another company, like De La Rue Print Track, they did currency. All they did was like currency, banknotes and stuff. Then I went to KLA 10 Core. Their KLA 10 Core hires a ton of people in imaging. If anyone wants to do semiconductor wafer inspection, KLA 10 Core is your company. They hire tons of people because they churn through them, and it's a pretty stressful environment. But they're in Silicon, they're Santa Clara. But all they did was semiconductor wafer inspection. And then I looked at MIT Lincoln Labs, and all they did was like missile tracking, And then I went to like P&G and DuPont, and they had such a huge variety of different stuff. It was not like you're working on fingerprints and that's all you do. There was like an incredibly wide variety of stuff at those companies. Another one might be like 3M, So I really encourage you to get a job that's not just working on one thing, because you'll probably get bored after a while. Pick a company that has like a wide variety of things you can work on.
Great.
So another one was a tile scanner. This is another line scan one, and these are like 8,000 by 9,000 images. So imagine you take like a glossy black floor tile, and then you put some kind of a fluid on there, like a Swiffer wet jet, and you want to see, well, how does a residue look? And we have residue due to both the soil that gets smeared around, like dust and dirt and stuff. And actually, Stephen, there's companies that will sell you vacuum cleaner dirt. Believe it or not, they collect vacuum cleaner bags from people, and then they filter them and mix them, and they can tell you get a certain amount of food soils, dust mites, hair, pet fur, and you can mix this up into a solution. You can put it on the floors, and then you can try to clean it with something like Mr. Clean or Swiffer.
Now I'm curious what the going rate is for a bag of vacuum cleaner dirt.
Yeah. And we actually have people who make our fabric stains. There's a company, and P&G's their only customer, and all they do is they stain fabric swatches and sell them to P&G.
Oh my gosh.
That's the whole company.
That's pretty cool.
We spend like $5 million a year on testing fabrics.
Right.
So, here's another one. It was kind of like the mugshots one. I looked at the mean intensity. Of course, we had to do a intensity both for, we had to do a shading correction. Do you go into shading, like, how lenses have shading?
No, we don't.
You better discuss that, because that's very important. Like,
sure.
the image is darker at the edges and corners than it is in the middle because of the shading on a lens. And if you don't correct for that, then you'll think something's darker at the edge when it's really not. It's just due to the lens only transmits 80% as much light at the side.
Right. Yeah, we do lens undistortion. We'll do that in module 7. So we compensate for the curvature of the lens, but not the intensity variation.
Yeah, I think the intensity variation is actually much more important than the geometrical distortion.
Yeah, very interesting. Yeah, I'm a little biased by my go ahead.
Well, at least if you're looking at intensity of stuff, maybe if you're doing
Yeah.
caliper type stuff, like what's the width and height of this, you might need to do that.
Mm-hmm. Yeah, absolutely.
And
Yeah,
another important thing is you might want to talk about telecentric lenses and where those are useful.
mm-hmm.
But anyway, so we look at this and we apply a whole bunch of different things like the average intensity. So we've also imaged a grayscale step wedge. So that way, if the image is slightly darker or brighter from one time to the next, we know how to correct for it. We can brighten it up to the standard brightness, even if the lamps got darker.
Right.
So we look at the profile, we look at the, we like fit a line to here and look at the residuals to see how, how wavy or uniform it is and things like that. So literally there's like 20 or 30 different things we measure for this. And ultimately they want to know, we're making a solution. We want to leave as little residue as possible. And how can you do that? Right now, if it's on the floor and they've got overhead lights and someone like looks there and they kind of move their head around and you see the reflection of the fluorescent lights overhead and you have to make some sort of visual judgment, this is, much more objective.
Right.
This is one when we're looking at anti-wrinkle creams like Olay. So we take a picture of like the crow's feet area of people's face, and then we do like a ridge detection. Someone else did this. I'm not exactly sure how they found the ridges, but some algorithm, maybe a Hessian filter, Frange filter, Sobel filter. I don't know, maybe they did an adaptive histogram equalization and then just thresholded it. I'm not sure, whatever the algorithm was. And it could be a combination of a bunch of different things to throw out like good and bad things. But anyway, they find the wrinkles and they mask out stuff like the eye and the hair and stuff like that. So you just look at this region of interest. And then so like here's the original one, and then here's like someone used the Olay Regenerist for 3 weeks. And this is what they look like afterwards. And they're all very, very precisely aligned, and the light's the same and everything. Not like these hokey things you see on TV where the lighting and everything's totally different. And then we can we can analyze the length of the wrinkles before, like 600 millimeters, and we can look at it after as 350. And so you can say, reduces the appearance of fine lines and wrinkles by 40% or whatever. And you put this on the pack, and you can sell just because of that. Oh, gee, that one claim made $60 million. Great.
That's pretty cool. And I just have one quick question for you. Of all the claims that Procter & Gamble will make based on different research studies, do you have an idea of what percent roughly would be from image analysis? I'm sure there's other non-image analysis methods you guys would use to do this kind of research or to make that kind of claim. Do you have a sense for what percent are image-based?
Not exactly. There's a lot of chemical-based things. And we have some other things that are like, you want to know penetration of retinol into the skin, and so they'll use like Raman spectroscopy, or they'll, I mean, there's a lot of chemical things, but I don't know. Probably image-based, let's say roughly 20 to 30%.
Yeah, that's pretty cool. I just think I think it's really interesting because I don't know about the students in the class. Like, before you start taking computer vision, it might not be obvious where the computer vision problems are. But man, I wouldn't you wouldn't guess necessarily that some of these research studies and these claims that companies like P&G make would be based on computer vision. I think that's pretty cool. Once you're kind of aware of computer vision, you see it popping up everywhere.
Yeah, so here's one we did for consumer kiosks. So we called it the beauty imaging system. It was for Olay, and there's actually a high-end thing. You can now actually get it in Costco. It's called SK2. I mean, a little golf ball sized ball of ointment in a huge glass jar is like $60 at Costco. And this stuff's incredibly, some of their jars are like $200. So here's an SK2 counter, and you can see there's a beauty counselor here talking through a customer. And here's a system. So the lady puts her face up here, and we take a shot of the lady's face, like up here. And then we analyze it for texture, wrinkles, pores, and spots. And I actually got a patent on this. And so we made like 700 of these things, and then we outsourced it to Canfield Scientific Systems, and then now they're selling it as the Visia system to spas and especially dermatologists. A lot of dermatologists out there have the Canfield Visia system, which is based on our work, and we have a patent for it. So yeah, this is like consumer or beauty counselor led, because there's a lot of psychology that goes into this, because you're giving percentage better than someone your age and race. So like if you're a 40-year-old woman who comes up and they say, oh, okay, you're better than 20% of people your age, this can be embarrassing to them, and they want to like go get out of there as soon as they can, and hide because they're embarrassed. And then a beauty counselor has to say, well, oh, I can see you look like an active person and a happy person. You probably smile a lot and spend a lot of time in the sun. So, but we can help you. We can reduce those fine lines and wrinkles if you just use the SK2. So don't run away. Or if you have someone who comes in and says, well, I'm using L'Oreal, or is that or Estee Lauder, or one of the competitors, and they get like a 90%. They're like, well, shoot, why would I want to change? I'm using a competitor, works well for me.
Right. Very cool. One question that came in about machine learning. So one thing we talk about in this class a lot is, what kinds of problems are appropriate for machine learning and what kinds of problems are more appropriate for analytical methods. And the question is, what is of the examples you've shown or the ones that you will show, where would machine learning fit in? Is machine learning a good fit for some of these problems? What are your thoughts?
Yeah, it can. It depends on the problem. We're starting to recognize some situations where machine learning might be good. It's usually when you can't, accurately define what you want. It's like, well, I kind of know it when I see it, but I can't really say that it's the width of this or the height of that or the color of that. It's just sort of, like, let's say you were looking at this woman's skin and you wanted to have a radiance score, or,
right.
Oh, her skin looks, when consumers look at this, they'll say, oh, her skin looks radiant, or her skin looks glowing, or her skin looks fresh. Right? How do you measure fresh? And so you can just have people like do human visual grading, and then you can try to use like regression to get like, a fresh score or something. But, you don't know, do I look at the histogram to see how radiant her skin is, or, is it the texture? Sometimes you can measure a bunch of that stuff and use a traditional model to sort of correlate them, or sometimes you can just use, deep learning.
Right.
But it's usually when things are not so cut and dried, they're like sort of like ill-defined and hard to describe.
Right.
We're running out of time here. So we got some MRI and CT instruments. Here's an MRI. We got nuclear magnetic resonance. Here's a big MRI. We got like a tabletop CT machine that's like here. This is like literally sits on a desktop. We got a larger one here, a floor unit. And so let me show you some. I'll see if I can. How do I get back to my? I think I gotta quit my pointer thing. No. How do I get my
Oh, it won't let you click.
Oh, here it is. Taskbar. Let me see. Oh, I'm going to show you a CT movie.
Great.
Okay, so and it probably won't show, will it? Unless I change my sharing options. Let's see. All right, so I think I'm going to have to stop sharing.
All right.
Briefly, and then I'm going to have to share the other thing. Let's see, is it started yet? There it is. Okay, now I got to find the share button. Share screen. No, share screen. Here it is. Windows Media Player. Okay, can you see this?
Yep, got it.
So do you see like all these fibers and stuff?
Mm-hmm.
Okay, so this is a like a non-woven, like the back sheet of a diaper or back sheet of a fem pad or something like that, or it could be a synthetic, paper towel or something. I'm actually not sure what this is, but we've done that, and then let me see if I can launch another one. Hopefully, it'll not require me to stop sharing. Can you see a bottle cap?
Yep. Mm-hmm.
Okay, so this is a micro CT doing a cutaway view of a bottle cap. I don't know, they do a lot of packaging studies, like, does the package leak or things like that, or they just want to, they do a lot of fitting studies. So a lot of times you make up a mold in a CAD/CAM program to like make a plastic part, and then you actually make it, and then now you got to see, well, how well did it actually fit our CAD/CAM model, or when the plastic cooled, did it warp and it has a different shape, or sometimes if you got trigger sprayers, there's some internal problems with the trigger sprayer, and so they use micro CT to look inside of them.
Very cool.
So got a whole bunch of those. Let me see, do one more, hopefully.
And would you do some kind of image analysis on a 3D image like that, a 3D point cloud?
Yeah, they do. They do. I
Cool.
don't, but people do.
Yeah.
They you basically want to find like the delta distance and on the normal from the CAD/CAM design to what actually got produced.
Right. Mm-hmm.
And
Very cool.
you might find that certain areas are moved a lot because, I don't know, the way the plastic cools or whatever. Then they can also do cutaway views, like you can, take like a Gillette Fusion razor and then just like remove parts and see what's left.
Mm-hmm. Very cool.
Okay.
So our event has just reminded me that we also have these 2 polls if we want to try to squeeze those in. We have about 10 minutes left.
Oh, okay. Let me look at the, let me go back to sharing my screen.
All right.
And, okay, share. I can go through some of these real quickly without talking about them.
Okay.
Okay, so at one time we owned thermocare wraps, and so we used a thermal camera to look at temperature distribution on someone's back. We looked at hair shine. The hair bent over the barrel and calculated the width of the hair and how bright it was inside and out. So we can also do consumer preference studies, like, this is a good situation where, you might use deep learning. Like you might say, how does this compare to this other one? People may say, oh, I like this, I prefer this one. They prefer actually this one on the left, 75 to 25 over the one on the right, but why?
Right.
We've done some eyelash simulation. So, you can start off with eyelashes that are just uniformly spaced and long, and then you can vary the length profile, then you can vary the width profile and the positionings, and then so you can do simulation studies like, how do you like this lash look? We're looking at teeth. You know how white they are? So this is our smile enhancement system.
That does not look comfortable.
So we have a way to automatically mask the teeth, and then we do a LAB, and so we get like the L and the B, and so before and after using white strips, and this is one, yeah. If you want me to talk about the Colgate lawsuit, this is pretty interesting. But anyway,
All right.
so this is what we use to, you can see here, these things here are all taken from image analysis. It takes 14 years off in 7 days. You know, whitens teeth in 1 to 2 weeks, whiter teeth for 6 months. And then Colgate did not like this, whitens 5 times better than Simply White.
Oh, wow.
So, right when we came out with Crest White Strips, and they were $40 a box, and then they came out with Simply White, which was like a paint-on thing on your teeth,
Mhm.
and it was only $15. And then, you know, we came out with this advertising. Their sales basically went to zero, and they ended up
Wow.
taking it off the market. And we said, well, because our data proved that their stuff just plain did not work. It just didn't work. And people realized that, and, you know, they stopped buying it. Well, they didn't like that, and they sued us for $79 million.
Oh my gosh.
And we fought back, and we got an expert in color, Roy Burns from Rochester Institute of Technology. Got him to, you know, vet our system, and he was a consultant in the lawsuit. And we fought back, and we won the lawsuit. There's one killer thing, because one thing we said was like, look, Colgate, look at the American Dental Association meetings, because they said, well, you're using LAB, and, you know, dentists don't use LAB. They use these like physical shade guides that are like little tooth chips, and they use that to compare, you know, and you didn't do that. You used LAB. And then we showed a whole bunch of Colgate articles like, oh, if LAB is so crappy, then why are you guys using it when you make your publications? Like, and then we during discovery, we had some documents by the vice president of Colgate said something like, you know, holy crap, their stuff really is better. It doesn't matter. We're going to sue them anyway.
Oh my
And
gosh.
once the judge saw that, it's like, you know.
Oh, was that in an email he sent or something that got discovered later?
He wrote it in. Back then, what the vice presidents used to do is that their secretaries would like print them up stacks of reports from the scientists, and then they would go through these things, and they would make little notations in ink on the margins, and then they would like send them back.
Right.
And so, you know, the lawyers got that during discovery, and we found out that a vice president, even before they took their stuff off the market, said that they were going to sue P&G anyway.
Wow.
And we've had other things, like another lawsuit where Henkel sued us for a glass cleaner, and they do what these distraction lawsuits, because they knew that their glass cleaner was not better than ours, Mr. Proper, which is what Mr. Clean is called in Europe, and so they sued us, and which was just a distraction because they knew our stuff was better at repelling raindrops. And we had to get the Fraunhofer Institute to come in and bless our system, and, you know, that took like 6 months. In the meantime, they were developing their own formula, which was going to be as good as ours and better than their on the market formula, and they knew that they were worse, but they sued us anyway, just as a distraction.
Oh my gosh.
Looking at teeth staining, plaque. We had a robot to brush teeth and see how we'd take the teeth out and see how well did the toothbrush bristles get in between the teeth. One time we used the MRI to look at the crispiness of French fries.
That's pretty cool.
You know, if you have like a crisp shell, you know, it's nice and crispy.
Right.
We've looked at shampoo. Here's one where we looked at silicone droplets in shampoo, conditioner droplets in shampoo. We looked at grease cleaning off plates in the dishwasher. Looked at Old Spice cooling wipes. We've looked at hair regrowth to see how well like Rogaine grows hair. Take close-up pictures of hair, find the hairs. We have a lot of 3D things. And yeah, there's a summary. You know all this stuff. So any questions?
Great. Well, we had one question pop up while you were delivering the last little bit. This might lead into our poll possibly. Actually, let me ask this one first. So Ashish wants to know, when dealing with large data sets, is it okay to resize images?
It can be. Yeah, I mean, certainly if I'm just looking at like big broad stains, like for the surface scanner, just because a thing can give you an 8,000 by 9,000 image doesn't mean I need that sort of resolution. So maybe like right off the bat, I just, if I resize it to a quarter of the size, I can still get the information I need, and it's going to be a lot faster to analyze it. But, it just depends if you need that spatial resolution or not.
Right, yeah, great. And then one more question, then we'll go to our poll maybe. So we had a few questions about hiring. So one question, are you hiring? Do you only hire PhDs? And do you have internships for undergraduate students?
Yes, we're not, as far as I know, we're not hiring right now. I probably am going to retire in 5 years, so I hope they're going to hire someone to replace me.
Right.
We are hiring people now. It seems like they are hiring chemist type people, or people who know how to run chemical instruments. But actually, we did just hire someone to work in the CT lab. He was a bachelor's, or yeah. Actually, I don't even think he graduated. I think he had some college. There is a push in the company to do less PhDs and more bachelor's people. But generally, I would say probably a third of the people have PhDs and the rest are bachelors. If you get hired as a PhD, you come in at like a higher level. You get paid more, of course, and you're at a higher on the the career track. If you come in as a bachelor's, you're lower, and it takes longer and it's harder to sort of work your way up the ladder. Usually, if you come in as a PhD, you're sometimes you're like I do my own stuff. Occasionally, I'll have a contractor where I kind of direct them what to do. But some of the other people, they'll have like, they do sort of like the thinking part of the job, and then sort of the routine putting samples in and out of the imaging rig or whatever. Those will be like bachelor's people. Don't really hire many master's people, so it's usually either bachelor's or PhD.
That's interesting. What's the reason for that?
Not really sure. I mean, if I had to replace someone for my job, I would say, well, I really don't think a bachelor's person is going to have, as much in-depth experience as a PhD.
Right.
So I would just want someone who knows more. I mean, you can just sort of start off at a higher level. I mean,
Right.
like how many bachelor's people know how to, program up deep learning or something? That might be something that you only get to that maybe when you're in graduate school.
Yeah, absolutely. And I think these are very relevant things to talk about for our students, because a lot of them are kind of in that boat thinking about, do I want to do the PhD? Kind of where do I want to stop? How do I want to balance industry with school, things like that. So I'm sure that a lot of our students appreciate that. Just one last question I had, and then I do want to get to the poll. You said there was kind of a push at P&G to move a little bit away from PhDs. What's the driver behind that, just out of curiosity?
Perhaps cost savings. I don't know. Perhaps I know there was a push for like people who were at sort of at the lower levels sort of felt like they were stuck being a lab rat, and the PhDs were always just sort of telling them what to do, and they found it hard to sort of move up in the company. And then so they wanted them to feel more valued, so they sort of made a career track for, I don't know, like laboratory research specialists, basically the hands-on people who actually, you know, touch instruments and do stuff, you know. And
Right.
then so that sort of gave them a career path, and then they're also cheaper than the PhDs, and the PhDs do the things that like require the, you know, the heavy thinking and analysis and stuff like that. Like if you're looking at conditioner on hair, you might say, well, the bachelor's might know how to run a TOF Sims instrument and how to get an image and say, okay, here's the image, and you know, can maybe even say, well, here's you can see that the cuticles are smoother here, you know. But then the PhD will say, okay, well, that's fine. We can see the cuticles on the hair are smoother, but why? What is it about the chemicals? Why does this chemical stick to the thing there? And is there some way to make it smoother? Or is there a different chemical I could do that would make it even smoother or silkier or something like that? They'll do that sort of, you know, more, I don't know, higher level kind of thinking.
Yeah. Yeah, that makes sense. Great. Okay, well, we're a little bit over time here. Maybe we can get in one poll real quick. So Arvind and Rohan, I think we have two ready. Maybe we can get in one. I think one was about who was considering pursuing a career in image analysis, I think was one of the polls. What was the other one?
How many were, was it how many going on to grad school?
Oh, I think that's oh, for the undergrads. That's right. That's right.
Yeah.
Right, right. Okay, well, if students can hang around, that's great. If you have to go, that's no problem. Let's go ahead and try to do both, just because I don't have a hard stop. Um, so so we have the first one open now. So yeah, how many people do you plan on a career for imaging, optics, image capture, image processing, and/or image analysis would be a major part? Yeah, so just yes, no. Throw your answer in there. That'll be interesting to see. We've got 43 students left. I think if you had to drop at the end, but that'll be that's not a bad sample size. So we'll keep that open for 15 or 20 seconds and see what you guys have to say. I'm going to predict 30%. That's my guess. Maybe 25. We'll see. Any predictions, Arvind and Rohan?
Well, I can see it live now. It looks like a lot of the people are making the right choice.
Oh, I can't even.
Yeah, about 74% have want to
Oh wow, I was
have a
way
career
off.
in imaging.
I'm glad we asked. Man, I was way off.
So
That's awesome.
These people are really interested in what you're showing, because this is going to be, you know, part of their career. It's
That's
not
pretty
just
cool.
some filler course.
Of course, yeah, that's awesome. I didn't realize it'd be so high. Great, yeah. So 71% of people are considering a career in this field. That's awesome, guys. I really didn't know that. That's really cool. Because I mean, you know, computer science is a big field, right? And you guys, there's many areas you could specialize in, right? So that's pretty neat. Great. Well, let's go ahead and run the other poll then. And this poll, I believe, is really just for the undergraduates. Although I think the master's students could answer as well because,
Yeah.
Yeah. Okay. Yeah. Sure. Basically, this would be PhD, right? Are you considering a PhD in something image related? All right. This will be interesting as well. I'm not going to venture a bet because I was so off on the first one. That was embarrassing.
Yeah, it's a little less. So I guess that's understandable. I mean, you want to take a broad cross section of courses because you're, you know, you want to see everything that's out there, and this is just one of them.
Yeah. Right. Yeah, absolutely. The PhD question is really interesting too. I get that question all the time, you know, should I go and do my PhD? And I don't know how to, I mean, it just depends on the company, you know, like I know my company, we don't particularly, not that we're against PhDs, but it doesn't really affect our decisioning too much, but we're not a research company, you know, so that it really depends on where you want to go. So yeah, we had 62% say no, and about 40%, that's a lot though, so 40% are planning to do further either PhD level, or if you're undergrad, that could be a master's or PhD in something image related. That's pretty cool.
Yeah, I mean, because imaging is fun, and
It
let's
is,
face it. I mean, I have vice presidents telling me, you know, hey, we got all of this stuff from the chemists, and it's like spectras and line plots and charts and tables, and they're like,
right.
this stuff, I can't show this to someone at Walmart. It's gonna be like way over their head. Give me some like nice images.
Right.
Everybody can understand images. Everybody loves images. Everybody loves videos and pictures.
Right. Absolutely. Well, great. Well, yeah, and Arvin made a good point. He said, right now students are actually picking their project topics. So this is all these examples were great to get students thinking about all the stuff you can do with computer vision. So great. So that was really awesome, Mark. Thank you for your time today.
Oh, you're welcome.
Great. All right. Well, I think that's all we have. I don't have anything specific to wrap up or anything. And we are a little over time, so we should probably go ahead and close. But yeah, thanks everyone for coming. I hope you enjoyed. We're getting a lot of chats now, a lot of thank yous. Great lecture. Thanks for coming. Thanks. So yeah, I think everyone had a good time. And yeah, this was our second guest lecture, guys. We'll have another one in a few weeks. But yeah, thanks for all the good questions too. This was really, really interesting. Hopefully, this is very different than our first guest lecture, and they'll continue to be. There's many things you can do with computer vision, and I think this was a really cool summary of all the stuff or some of the stuff you can do in research for a company like P&G. So Monica says, "I believe in P&G more now." That's pretty funny. Great, awesome. Well, great. Well, thank you again, Mark. That was really great.
All right, thank you.
Yeah, great. We'll be in touch, and thanks for your time.
All right, bye.
All right, have a good one.